Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today, guys, we're going to wrap up Chapter 8 by talking about how to solve systems of inequalities. You guys remember inequalities, right? Less than, greater than, all that good stuff. Well, in order to solve systems of linear inequalities, simply graph and shade each inequality, individually. The area of the system which was overlapping, okay, which has overlapping solution sets, that's the solution of the system. There are infinite number of solutions for systems of inequalities because they are shaded values. They keep going on. When you have a system of just linear equations, you have one point of intersection, or no points of intersection. In that case, it'd be no solution, or an infinite number of points of intersection, which would be all real solutions. But here, it's not just one point. So in this particular case, my brothers, it's very important for you to graph neatly and accurately and to shade in a common sense way. And I'm going to explain what that means right now. If I were to tell you what is the solution of a system of inequalities, and I give you this system, first of all, please do not attempt to solve this by elimination or substitution. It cannot work. It will not work. So please do not do that. And let me rephrase that. It's not that it can't work. It's just that you're going to be left with inequalities at the end. And what do you have to do with those inequalities at the end? You're still going to have to graph them. So please just solve this by graphing. So very simple. We know how to solve by graphing. We're going to first solve for y. So I'm going to go ahead and do this guy here. We're going to call this number 1, and we'll color that in red. If you so choose to have a pen and a pencil for this, or colored pencils, or different colored pens, if you so choose to use a highlighter, okay, anything that will help you differentiate between the two inequalities, that is more than fine with me. Even if it's as simple as, okay, I'm going to use a black pen and a regular pencil. That's fine, if you so choose. So I'm first going to solve for y, guys. So I'm going to subtract x to both sides. And I've got y is greater than negative x plus 4. Bam. Let's go ahead and graph that bad boy. What's my y-intercept here? 4. Thank you, my brothers. 1, 2, 3, and 4. And what is my slope here, gentlemen? Negative 1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Let's go backwards. Up 1 over 1, up 1 over 1, up 1 over 1. I like to, give myself a nice wide graph. Now, I have greater than. So is that going to be shaded or dashed? If you guys remember, dashed. Very good. We never did dash, but remember we had open circle or parentheses, and then we had closed circle or bracket. Well, here it's got to be quote unquote an open circle. None of the points on this line are solutions. Nothing that lands individually on the on the dashed part, none of those are solutions. That's why it's dashed, guys. It's dashed because it's telling the reader, hey, reader, listen, this is the graph of this inequality. These are going to be the solutions. We're going to shade them now. But the line itself does not hold any solutions. Okay? So it's like if I were to tell you, hey, only people that are older than 16 can go, whatever, see this movie. Can you go if you're 16? No. Older than 16. Can you go if you're 16? No. That's what a greater than or less than means, okay? So the line itself does not hold any solutions. How do I shade it? Well, this is the way most people are taught. Okay, boys and girls, just shade. Please do not do that. That is messy, it's inefficient, and it's just sloppy. And the reason that you don't do that is because if you have this one shaded, and then you graph this, and then you shade this, how do you know who's overlapping what? Do you know what I'm saying? So what I do, guys, I know I'm a little bit intense, but I create a checkerboard. So first of all, Y is greater than negative x plus 4. Look at the y-intercept. Are the values above that y-intercept or below that y-intercept greater? Above. So whenever you're doing greater than, I don't care if the slope is positive or negative, you're going to shade above the graph. And guys, literally, just make yourself some straight lines. Yes, sir, my brother. If you have a vertical graph and it's greater, you go to the right. If it's less than, you go to the left. If it's a horizontal graph, greater is above, less than is below. Yes, sir, my brother. Thank you. It only depends on the inequality, how I shade. Doesn't matter what the value of the y-intercept is. If it's greater than, you always go above that graph. And if it's less than, below that graph. Yeah, Papa. No, please. Correct. Correct. Some teachers go ahead and some books, there's nothing wrong with this. But what they'll tell you is, all right, guys, pick a point here, test it. Pick a point here, test it. The side that actually works, that's where you shade. That's great. That's accurate. It's 100% awesome. But it's time consuming. So trust me, guys, I've done this a long time. If it's greater than, just look at that y-intercept. Greater than, you're going to go above the y-intercept. Less than, below the y-intercept. Now, let's do this next one. This is number 2. So this is 7y equals negative 3x, less than or equal to negative 3x plus 21, divide by 7. Y is less than or equal to negative 3x over 7 plus 3. Hey guys, just real quick, if I had divided by a negative 7, what do I do to inequality? Flip it. Thank you, guys. So what's my y-intercept here of this blue inequality, y'all? 3. So 1, 2, 3. Okay. What's my slope, guys? Down 3 over 7. So I'm going to go 1, 2, 3 over 1, 2, 3, 4, 5, 6, and 7. And I'm going to go up 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7. Is that going to be a solid or a dashed line? That's going to be solid. Now, pay attention, gentlemen. Am I going to shade above or below? Below. Now watch. Do you think I should shade this part here? Why? Very good. That's just one side you're not overlapping anything there. So I don't even waste my time on that side. I know that I'm going to come down here. And why do I know? Because I have my little checkerboard pattern here. So then at the end, my answer or answers is everything in this purple little area. All of this, those are my infinite number of solutions. So any point in that purple region will work, guaranteed. And you can test it. If you test it and it doesn't work, then no worries, erase it, go back to the drawing board. You messed up. Okay. Does that make sense, guys? It's not bad, right? Questions, comments, concerns? Okay, next. Yes, sir. Please, sir. Thank you. I'm sorry. What is it? This is the solution set right here. That's the solution set. What is the solution? What is the solution of the system? What is the solution? Anything inside of here.
Wouldn't it be more correct to a domain and range though to be more accurate?
I'm not asking for the domain and range though here. That does not really give you the solution. That gives you the valid x's and the valid y's. If I wanted to find the domain of the solution set, well, it starts here, so it'd be 1, 2, 3, but it's not 3. 3 can't be included, so it'd be from 3 to positive infinity. Okay, that would be my solution set for D. Not my domain for the solution set. My range would be from 1, and actually, wait, gotta go back the other way. Negative infinity to 1. So you're right, that I can find the domain and range, but that doesn't give me the solution set. Solution set here is an infinite number of problems. I'm sorry? I guess this should be what are the solutions. And the solutions, literally, in an SAT and an ACT, they'll have this graph like this, and they'll have three different graphs, and they'll look for which is the correct solution set of this system of inequalities. The one that looks like this, that's the answer. They can't tell you, okay, it's going to be 5, 2, and 5, 3, and 5, 4, and 5, 5, and 5, 6, because literally there are an infinite number. Now, I can say to you, find 3 solutions in this solution set. Then I would say, okay, one of them is, let's say here, right, let's do it in black ink so you can see it. So that'd be 1, 2, 3, 4, 5, 6, negative 1. That's a solution. Let's say this guy right here, 7, negative 1. That's a solution. Let's put this guy right here, which is, actually that was 8. This would be 9, and then 1, 2, 3, 4, 9, negative 4. That's another solution. But no, you do not write solutions as domain.
So the SAT question, they will never give you that. They will give you as answer choices, domain and range.
No, they will never give you as chances domain and range, excuse me, for a solution set. Because a solution is an ordered pair X and Y. What the domain and range will tell you, what are all the possible X's and Y's in this solution set, but it's not giving you the solutions. Does that make sense, brother? Thank you for that. I appreciate that question and your honesty. Thank you. All right, guys, let's do it another one. What is the solution? I guess this should be a little bit better rephrased. How about this? Find the solutions of the system of inequalities. And then that way, you know, maybe that's a little bit easier for you. You're looking for that shaded area. So what I'm going to first do here is, of course, solve for y. So I've got negative y is greater than or equal to negative 2x minus 3. I'm going to divide by a negative 1, gentlemen. So I've got y is less than or equal to 2x plus 3, because since I divided by a negative, I flip the sign of the inequality. My y-intercept is 3. My slope is 2, so up 2 over 1, up 2 over 1, down 2 over 1. This is going to be a solid line. And am I going to shade above or below, since it's y is less than or equal to? Below. So I'm literally just going to nice and neatly shade below. Now in blue, my brothers, we'll solve this bad boy. It was already given to you nice and easy, already in slope-intercept form. My y-intercept was 1. My slope is negative 1/2. So I'm going to go down 1 over 2, down 1 over 2, down 1 over 2, up 1 over 2, up 1 over 2. Solid line because it's greater than or equal to. And am I going to shade above or below? Above. So I'm going to shade above. Guys, do you see that beautiful checkerboard? That, my brothers, all of these guys, these are all your possible solutions. Yes, sir. I did change the sign from greater than to less than. Thank you, my brother. And then on a test, you could just kind of point, say solutions. Because again, on an SAT, they're going to have a graph, and they're going to have different shaded areas. The correct shaded area is what they're looking for, and those are the solutions of a system of inequalities. Not too bad, right, gents? If you know how to graph, it's pretty simple. Just remember, be cognizant of shading. That's the part that gets a lot of people. Okay, how about this guy? Oh, nice and easy. What's my y-intercept? We'll do it again in red and blue. 1 and 2. For my red equation, gentlemen, what's my y-intercept, please? Negative 5. 1, 2, 3, 4, and a 5-er. All right, now what do we do? What's my slope? 3 over 1. Fantastic. So I go up 1, 2, 3, 1 to the right. Always run to the right unless going backwards. Up a 1, 2, 3, and a little righter. 1, 2, 3, a little righter. Down 1, 2, 3, a little righter. Bam. Solid or dashed? Solid, because it's greater than or equal to, so it's solid. Am I going to shade above or below this bad boy? Y is greater than, so I'm going to go above. Thank you very much. Again, I'm not looking for art, guys. I'm actually just looking for neatness, because the neater I make it, the easier I'm going to detect my little checkerboard. Now in blue, I'm graphing my next equation. What's my y-intercept for the next equation? Please. 5. So I got 1, 2, 3, 4, and 5. All right. What's my y-intercept? What's my slope? Please. Darn right. Down 2 over 1, down 2 over 1, down 2 over 1. Am I going to go dash or solid? Solid. Am I going to shade above or below? Below. So below, blammo. My checkerboard, that's why I do it, by the way, guys. That stands out to you. Even if you did it in the same color, even if you did it with just all black pen or all blue pen or all pencil, you make that checkerboard, you don't have to worry about the colors. Your checkerboard, that's your answer. Your answers are all within here. You don't have to do this that I'm doing in green, but this is for you guys. All of this, all of that, those are my solutions. There's an infinite number of solutions. Does that make sense, gentlemen? May I continue, more importantly, gentlemen? Thank you, brothers. All right, what is the solution of this bad boy? All right, let's do it. Let's go. All right, let's do it. Red and blue. Okay, let's get my red here. I'm going to subtract 2x, so y is less than negative 2x plus 7. What's my y-intercept here for my red inequality, please? 7, 1, 2, 3, 4, 5, 6, and 7. What's my y-intercept? My slope, please? Negative 2 over 1, so I'm going to go down 1, 2 over 1 to the right. Down 1, 2 over 1 to the right. Down 2 over 1 to the right. Up 2 over 1 to the right. Bless you. Dash or solid? Dashed. Do I shade above or below? Below, because it's less than. Very good. So we're going to shade below. Blue. We got negative 2y is greater than negative 7x plus 4. Divide by little negative 2 action. What happens since I divided by a negative 2 to this guy? Darn right. Thank you very much. That becomes less than. That's going to be 7 halves x minus 2. What's my y-intercept, y'all? Negative 2. Very good. Oh. Do not like it when that happens. Okay. Negative 2. Let's see. Okay. We're going to try this again. Maybe it'll work this time. Yes. Okay. Negative 2. What's my slope, please? Up 1, 2, 3, 4, 5, 6, 7 over 1, 2. Down 1, 2, 3, 4, 5, 6, 7 over 1, 2. Am I going to go dash or solid? Dash. Very good. Am I going to go above or below? Below. Guys, this is why it's so important shading so neatly. Look, below is coming here. So, everything in this little area, those are all my solutions. Questions, comments, concerns, problems, issues, dilemmas? Yes, sir? Yes, sir. No. Please get that out of your head, domain and range here. You do not find solution sets by finding a domain and range. No. All the domain and range tells you is the valid x and y values. But it does not tell you the solutions. Please do not think of that anymore. Thank you, my brother. Thank you. Guys, I don't have time. Oh, yeah, this is an easy one. I do have time for this. I wanted to go to the word problem, but this is real simple. Okay, let's do 1. Let's do number 2. Now, let's see who remembers these. Guys, what kind of a line is a y equals? Horizontal. Very good. Thank you, my brothers. So 1, 2, 3, 4, 5. Solid line. That's my y is less than or equal to 5, and it's less than, so am I going to go above or below? Below. And then I have my x is greater than negative 3. So that's going to be a horizontal or a vertical line? Vertical. A little negative 1, 2, 3 action. Ah, thank you. You caught me. Good job. Dashed. 1, 2, 3. Thank you for that. But oh, all right. Okay. dashed. Thank you for that. Am I shading above or below? I mean, or to the left or to the right, rather. To the right. So guess what, guys? Everything in here, all this, those are my solutions. And yes, including this top part. Yes, because that's solid. Not including this part. Very good, man. Very good. All right, guys, I know we got to go. I got 3 minutes. I'm going to do one word problem, okay? Just because that's the way it goes. And they're very important to know how to set this up, guys, because it makes your life infinitely much easier. Okay, for example, your city's cultural center is sponsoring a concert to raise at least $30,000 for a city's youth service. Tickets are $20 for balcony seats and $30 for orchestra seats. If the center has 500 orchestra seats, how many of each type of seat must they sell? Well, this is very simple, guys. First of all, label, 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 label. Balcony, I'm going to call B for balcony, because it makes sense. And orchestra, I'm going to call O for orchestra. Pretty simple. Now let's see the system they gave us, brothers. They say that it's $20 for balcony seats, so 20 bucks for every balcony, plus 30 bucks for every orchestra, O, must be greater than or equal to $30,000. Why, Moro? Because it said at least $30,000, correct? Right? And then here it says if the center has 500 orchestra seats, how many of each type of seat must they both sell? Okay. Who's orchestra? Who do we call? O, right? Okay. And you know what? I don't like the O thing because you're going to have to have an X and a Y, but that's okay. So O, it must be less than or equal to 500. What am I doing? Well, right now what I did was set myself up for the following situation. I'm going to call B the x-axis and O the y-axis, okay? Real quick, guys. O is less than or equal to 500. So here at 500, I've got a straight line, and I could go anywhere from 0 people to 500 seats. Does everyone see and understand that real quick? Now, guys, remember the intercepts? How you can make one variable 0, and then you get the value for the other one? Okay. Well, when I make B 0, guys, how much orchestra am I going to get? What's 30,000 divided by 30? 1,000. Very good. So, guys, that's my O intercept. So here at 1,000, I have a point. What's my B intercept? When this guy is 0, what's 30,000 divided by 20? 1,500. So this is 500. This is 1,000. Let's call this 1,500. Guys, you have 2 points. Guess what? Connect those dots. And it's going to be greater than, correct? So I got a shade here. So how many seeds can I sell? Any combination inside of here. Any combination inside of there. Yes, sir. Well, that means that I can sell, let's say right here, I can sell this point right here. I can sell 1,500 balcony, and let's just say that this is relating to like 250. I can sell 1,500 balcony and 250 orchestra seats. Or I can sell 1,500 balcony seats alone. Or I can sell, let's say, 1,000 balcony seats and 400 orchestra seats. Any of these, any combination in here would be a solution. No, thank you. Yes, sir. I'm sorry? This is greater than because it says at least. And at least means greater than or equal to. At most means less than or equal to. Yes, sir. Thank you, man. Guys, I hope you learned a lot. Hope you had a good day. May God bless you. Thank you very much. Bye-bye.